Okay guys, how's it going? This is going to be one of our last videos on kinetics, but I think it's a fairly important one if you plan on going to any further chemistry classes, and this really does provide a really great understanding of how reactions work, and they give you a lot of insight into the energetic components that drive how fast reactions actually proceed with. So let's continue and let's read this question. Most reactions occur by a series of steps. And the energy profile for a certain reaction that proceeds by a two-step mechanism is this graph that we see. On this particular graph, we're instructed to label the positions of the reactants and products, the activation energy for the overall reaction, the delta E for the reaction, the change in energy for the reaction, and which point on the plot represents the energy of the intermediate in the two-step reaction. And which step in the mechanism for this reaction is rate determining, the first or the second reaction, or second step. So let's do some labeling. Let's look at A. So the positions of the reactants and products. And this is a fairly easy part of your graph. It's just going to be the beginning and the end of your graph. So here in the beginning will be our reactants. So that's going to be our reactant or reactants. And at the end, that's going to be our products. That's fairly intuitive. Done with that one. The activation energy for the overall reaction. Well, that's going to be pretty interesting. So what I like to do is I draw a straight line from my reactants all the way to the end of the graph, like so. So the highest bump is going to represent the overall or the net activation energy for the reaction. So in that case, that would be this ridge that we see right here. And I'm going to abbreviate activation energy as E sub A, as you see here. So that's our activation energy, the largest hump in the graph we see. The delta E for the reaction. Well, the change in energy, remember that change always means final minus initial. So we need to evaluate our final energy versus what we started with. So what was my final energy? Well, remember that this graph, the y-axis, represents energy. So as I go down the graph, I'm going down in energy, and as I go up the graph, I'm going up in energy. So my final energy would then be where I am at the products, right here. And my initial energy is where I started. So this region here, from here to here, is my change in energy. And as you can see, my final energy is greater than is less. I'm lower on the graph, so I have less energy in the products than I do in the reactants. And as a result, that delta E is going to be negative. So it's going to be a negative delta E. And that's important because that gives us some insights into stuff we learned in Chemistry 101, which indicates that a negative delta E would represent an exothermic reaction, where our energy is lower in the products than it was in the reactants. So that would be our change in energy that we see. Go from the bottom of your graph to the top, or rather from your products to your reactants. And that's why that line was so important, because we can draw a nice line right here to indicate the change in energy. D, at which point on the plot represents the energy of the intermediate in the two-step reaction. So that would be the ridge in between the two humps of right here that we see. So that would be my intermediate. Remember that when we're doing mechanisms, the intermediate is the thing that's crossed out between when you have two elementary reactions. The intermediate that does not persist into the reaction at the end of the reaction. Okay, now, which step in the mechanism for this reaction is rate determining, the first or the second state, or second step? Well, remember that the rate determining step is the slow step, meaning would precede the slowest, which from an energetic standpoint means requires the most energy to surpass. So if we were to look at the two different humps that we see, the second hump clearly requires more energy to pass. And what that means is that in the mechanism, the molecules need to arrange themselves in such a way that they hit each other at just the right angle, and that the number of molecules collide in such a way to provide the energy required to proceed and break bonds and form new ones. So when the second step has more energy, that's just telling you that the second step requires more time. And from a kinetic standpoint, The slower step is the one that requires more energy. So as a result, the second step is the rate determining step. And that's because it requires more energy as a result. It requires more energy. Okay, so we kind of went over a lot right there. So remember that on our graph, the reactants and products are at the beginning and at the end of our graph. The activation energy is represented by the largest hump going to at the peak of our little humps there, we say that's our reaction, our complex or our coordinate. And we said our delta E is from we draw a line from our beginning to the end of the graph, and we accommodate for the change in height, and that would be our delta E. Okay, so and which one represents the high energy intermediate? That would be the dip in between the two humps that we see on the graph. Okay, I hope this was helpful. This tends to be something there is a lot of information packed in these graphs, so it is understandable that a lot of people have some difficulty with them. So I hope this was helpful. We'll see you in the next video.